Welcome to Building Real-Time Data Pipelines with the Couchbase Kafka Connector. Here's our agenda. I'll start with an oh-so-brief introduction, and then I'll talk about some common use cases and present a specific example which will include a bird's-eye view of a sample Couchbase Kafka architecture. Then I'll take a step back and look at exactly what is the Couchbase Kafka Connector. And I'll present an example using a source connector showing how it is configured and inspecting the messages that are produced. I'll complete the pipeline, putting it all together, and then have some closing thoughts at the end that you don't want to miss. All right, let's get rolling. I don't like to take a lot of time on intros or session overview because you've probably already read them as you were looking through which sessions to attend. My name is Ryan Atkins. I'm a principal consultant for Inspired Intellect. I've been working recently on an event stream processing application framework, which happens to incorporate the Couchbase Kafka Connector. And so I thought it might be beneficial to others for me to share some of my experience. So again, here is the overview. I've already talked about most of this in covering the agenda, but I wanted to include these intro slides here for those who may only be getting the slide deck without any other context. But let's begin, shall we? One thing we know about data within just about any organization is that there is an awful lot of it. It is generally coming in through many different sources. It is probably being stored on in many different ways, and it most definitely is being used for a wide variety of purposes. In fact, it is often the case that even the same bucket of data is useful to multiple departments within a single organization, but for entirely different purposes. It quickly becomes essential that you have an effective mechanism in place to not only manage your data, but also to provide conduits for your data so that it may flow purposely throughout your organization. You may think, for an example, of a healthcare provider that needs their care workers to have access to composite patient profile. Several data feeds contribute to this patient profile. You might have one feed for patient medications, one for patient allergies, and another for member information. These are all managed separately, but by implementing an effective data hub using event streaming data conduits, you can ensure that the care workers have the latest and most comprehensive knowledge of the patient. Or you may think of a financial services company that needs to aggregate data from multiple sources in order to manage risk, detect fraud, facilitate payment processing, and optimize financial planning using predictive maintenance models applied to real-time streaming data. There are plenty of other examples in retail, manufacturing, transportation, and other industries. Okay, so consider that we have a need to build a data pipeline. Before you start solutioning, there are several questions you should be asking before you begin. Specifically, with respect to building a data pipeline, you should consider these three questions. What are your data sources? Are they database management systems? Are they file systems? Are they in the cloud, or are they on-premise? Or more than likely, some blending of all of these things. What is the nature of your data? Is it structured or unstructured? Does it have schemas, or is it schemaless? And finally, what is your data delivery mechanism? How are you getting your data into these systems? Is it through manual entry, manual uploads of data? Are you running batch processes or scheduled jobs to import your data, or is the data coming in dynamically through some real-time streaming? All these things are important to understand when implementing a data pipeline strategy. Let's consider the following simple example. You have a travel service where users search for travel and are presented results as a list of options ranked based on the criteria that the user entered into their search, along with time and cost considerations. The data is sourced from Couchbase, and the search results are achieved by running optimized nickel queries. All the user search results are also stored in Couchbase for a limited amount of time, so a user may recall them quickly. All that is working swimmingly, but now we have a request from another department in the organization. The data warehouse team has requested that all of the search results be delivered to an in-house data warehouse, where a data insights team uses this data to learn about user tendencies and improve service offerings. Let's assume they have a Kafka event streaming platform already in place. And the data warehouse folks need the data to flow into tables on a Microsoft SQL server. Okay, no problem. We can build a suitable pipeline using the Couchbase Kafka Connector. Let's look at how such a pipeline might be constructed. Now, I'm going to gloss over this just a bit right now because we haven't talked about all of these components yet, but don't worry, we'll be coming back to this diagram later. For now, you can read this left to right. So we're starting with Couchbase as our data source. We are sending that data through the Couchbase Kafka connector into our Kafka streaming platform and out through into another connector, a Kafka Jdbc connector, which shoots the data over into our SQL server as requested. That is your proverbial big picture. Now, let's back up just a bit and talk about what we're here to talk about, the Couchbase Kafka connector. What is the Couchbase Kafka connector? Well, it's just a package, but I like to think of it as a set of four pieces. And the first is you begin with your foundational components, which is Kafka server and Couchbase server. You have those in place, and then you add in Kafka Connect integration framework. This is a generic programming framework that allows developers and vendors to develop connectors in order to integrate their data solutions and their data platforms with Kafka. So then we get to the actual Couchbase Kafka connector itself, which is essentially a specific implementation of the Kafka Connect framework that works specifically with Couchbase. And generally, when you build a connector for Kafka, you build it to support two different types of connection. And those two connector types are source and sink. A source connector is a type of connector that is going to take data from your platform, in this case Couchbase, and send it on out to Kafka. Whereas the sink type is the opposite. It's going to accept data coming out of Kafka, and it's going to put that into your data platform, or in this case, Couchbase. So generally, you always have those two. You support those two types in case you want to go in either direction. All right. So what do we need to what do we need to do to get up and running? Both Kafka and the Kafka Connect framework compile to Java, so you will need to have Java installed on your host server. The latest version should do just fine, although many earlier versions will work fine as well. I was running JDK 11 on my recent connector projects. You will also, of course, need the Kafka streaming platform. You can use either Confluent Platform Kafka or your basic Apache Kafka. Most likely, this is not something you're going to have to worry about, though, unless you're truly starting from scratch. If you are looking to use the Couchbase Kafka Connector, there's a good chance it is because your organization already has Kafka in place along with Couchbase, and there is a need to facilitate the flow of data into or out of Couchbase. Finally, we need the Couchbase Kafka Connector package itself. The package includes a jar file, configuration files, examples, and light documentation. Just one note here that the screenshot here is showing you the 3.4.8 package. Version 4.0 was released in August and has a slightly different file folder structure. For example, instead of a single jar file, there will be multiple jar files because the dependency classes have been broken out into their own jar files. And there's a few other small changes, but don't worry, all the information here is still relevant. There are configuration property name changes and changes to the Java API for building custom extensions. But there is also a well-documented migration guide and even a script which will convert your 3.x config files for you. So no worries there, whether you're using a 3.x version or the new 4. Version. By way of an example, let's look at how you would stand up a Couchbase source connector. Installation is simple. Just download and explode the package where you would like to run it. To get up and running quickly, the package includes sample configuration files for both source and sync connectors. You will notice that there are two formats provided for each connector type, a properties file and a JSON file. Use the properties file to run the connector in standalone mode. This is a good approach for getting something running quickly and you can test and develop on. In a production environment, you will most likely want to run in distributed mode across multiple worker nodes so that your connectors are scalable and fault tolerant. The reason that the formats are different is that when you run in distributed mode, connectors are managed over a REST API and you will post your configuration using a JSON payload to the REST API. Here is our properties file for our source connector. For our example, we have the following configuration. Many of these are defaults, and I won't go into detail on all of them. But if you open the sample properties file included with the package, you will find detailed documentation for most of these configuration properties within the comments of that file. I've removed all the comments here just so we can focus in on the properties, but be sure to look at the properties file, even if you're going to be running distributed, because comments aren't allowed in JSON files, so those examples do not have the documentation. And this one threw me for a loop. When I was first building my first connector, I was having a hard time understanding what some of these properties were until I realized they were all pretty well documented right in the sample properties file. So make sure you look at those comments inside of that file. So I would like to point out a few of these important properties that you will need to change from the sample files to be able to use the connector in your environment. Let's start with a topic name, topic.name. This is important because this will be the Kafka topic that gets created. think of it as the channel over which event messages from Couchbase will be sent. You may certainly pre-create this topic in Kafka, especially if you want it to be configured any differently from the default topic settings, which will be applied if the connector needs to create the topic on the fly, which it will if it does not exist. Here, we set our topic name to travel sample. We'll need to remember that later. Connection, all the connection properties define how to authenticate and connect to Couchbase and which bucket to source from. The dcp.message.converter class determines the structure and contents of the message. I only mention that here because we'll come back to that later, as this largely depends on the needs of your pipeline and how you want, what you want your messages to look like. The stream from property, this determines from what point in time to begin sending messages. In this case, the setting of saved offset or now means that when I run the connector, it will begin where it left off if it had been previously running and saved an offset. Otherwise, it will just begin from right now. Persistence polling interval. At the bottom, this one is a short delay intended to avoid prematurely sending a data mutation event before it has fully persisted. Well, this can create some lag. It guards against cases where you may have a data rollback. Note that one thing to note here, though, is if you have specified an ephemeral bucket in your connection.bucket property, you must set this to 0 to disable the persistence check, because ephemeral buckets don't persist documents. This one got me when I set up my first connector against an ephemeral bucket. However, this is documented in the sample properties file as well. So here's the JSON version of that same set of configuration properties, just to show you what that would look like in JSON form. And this would be what you would send as your payload to the Kafka Connect REST API when running in distributed mode. So again, I had mentioned I was working with 3.x, and what we just went through, some of the properties I talked about were referencing 3.x names. So some of the names have changed. Here are the same configuration settings and how they would look like after migrating to version 4. Most changes were simply to ensure a consistent naming convention. So I mean, you can see that our topic.name is in 3.x is couchbase.topic in 4.0, and a lot of the other ones are just slightly changed to align with the new naming convention. And don't worry about this, because these are all really well documented, and the new package includes a script to automatically convert legacy property names. So no issues there. User role settings. This is a gotcha, and it got me when I set up my first connector. Whichever user you have configured to use with your connector, you will need to ensure that said user is defined in Couchbase with the data DCP reader role. This is a data service role, and it may be configured for all buckets or on a per bucket level. I would recommend creating a new user in Couchbase specifically for this purpose. And of course, you can get to this dialog from the Couchbase web console in the security section. DCP is Couchbase's data change protocol. If you are familiar with CDC, or change data capture, common in other database systems, This is a similar concept in that it is used to capture change. All right, once you have things configured, running the connector is straightforward. You can simply kick it off from the command line, or you could set it up to run as a service. You only need to make sure that the connector jar file or files are in your environment's class path variable. Check the quick start guide on couchbase.com for the different ways you can get the connector up and running, depending on what sort of, whether you're using Apache Kafka or Confluent platform Kafka. Once the connector is running, if you don't have a consumer at the ready, you can spin one up simply enough. Spin up a Kafka consumer on the fly and begin observing messages. You can just run this command for to start a Kafka console consumer on the travel topic and let it fly. All right, so to test this out, we use our good old travel sample bucket, and we add a new airline document. And here we're just doing this from the console. We're adding document and typing in the JSON for our airline 101, Texas Wings Airline. Shortly after I click save, we will see a message sent to the Kafka topic that we had configured earlier. What we see in the message is a JSON structure with two parts, a schema and a payload. The schema is going to tell you exactly what fields to expect in the payload. And the payload is going to include metadata about the document and the event that occurred. Here on the left, I've truncated both fields to allow them to fit on the screen. On the right, you can see the full payload. The event field tells you if this was a mutation or a deletion. A mutation can mean an add or an update, and a deletion can mean a delete or an expire. They may be adding a separate mutation event specifically for expiration later, but I don't believe that is there yet. So you will either get mutation or deletion. The key field gives you the document key, and the content field will include the base 64 encoded string representation for the entire content of the document. That's why you see the jumbled up string there. And also note that that content field will be null if the event is a deletion. If we apply a simple conversion to the content field, you will see that it is exactly the same as the Couchbase JSON document. Now, depending on your needs, it is important to know that it is a simple matter of configuration if you wish to only have your message contain the exact JSON document. So what you see in this dark purple area could be your entire message. You would just need to change the Couchbase source handler class from using the schema source handler to using the raw JSON source handler. Pretty simple. But let's go back to the pipeline we set out to build. In this example, I just want to send the data directly into our SQL Server table. If I keep the schema payload format, then there's hardly anything left for me to do. But I do need a consumer. And for that, I've created another connector. This time it is a Kafka Jdbc connector available from Confluent. Again, this is my consumer, so I only need to configure to listen for for messages on the same Kafka topic and give it the name of a table where I want my data to land. So in this most basic of cases, since I'm including the schema in the message, I can just have the connector automatically create the table for me. So when we have all this running like a well-oiled machine, and you add a new document, the message will go through the pipeline and go through the two connectors, and you'll see a new row showing up in your table that has the same columns that reflect the schema and the values that were provided in the payload. So all the column headers that you see here is coming from the schema, and all the values that you see at the bottom are coming from the payload of the message that we received. So it went straight into my travel sample table that I specified in my Jdbc connector. So again, if I run a simple SQL statement here at the bottom to convert that content field, I can see that it is the exact same document that I added. So this is my converted content value, and it is my Texas Wings airline. Excellent. So what's next? Well, I hate to say it, but we've barely scratched the surface of what you can accomplish with the Couchbase Kafka connector. There is a lot you can accomplish simply through configuration. And I always opt for configuration over customization when at all possible. However, you can implement your own custom extensions to the connector using the Java API, and there are examples included in the Couchbase Kafka Connector package for doing things like filtering messages and single message transforms. You could also add worker nodes of your own into the pipelines to implement more advanced ETL type processing. For example, you might want to build your own consumer to take the raw messages from Couchbase and use them to build new enriched messages to send to one or more different and new Kafka topics. So let's review our sample architecture one more time. We've very quickly spun up a pipeline which uses a Couchbase source connector to produce messages to a Kafka topic, and then added a Jdbc sync connector to consume those same messages and store the data in SQL Server. Without much effort, like I said, you could add a worker node to be your initial consumer, perform some validation and enrichment, and then produce one or more new messages. So you could put that worker node in here to intercept the topic messages coming out of Kafka before they get to the Jdbc connector, and do whatever you want with them, validate them, filter them, enrich them, and then send them out to Jdbc or to other topics that may be getting consumed further downstream for other purposes. So don't forget though, this is just an example. You could just as easily have built your pipeline the other way around, like so, using SQL Server as your source and using the Couchbase sync connector, the sync version of the connector, same connector, different type, different configuration, and you would then have that data flowing into Couchbase. You can do this too. You might easily have a use case where you want to build a pipeline from one Couchbase bucket to another. No problem. Easy to mix and match and create all kinds of different pipelines to serve your needs. and it's fun. At least I had fun. In closing, I did want to mention a brief word about Couchbase eventing as something that you should explore as another option, perhaps even a preferred option for responding to data mutations. It all really depends on what you're trying to accomplish and to some degree what your existing data landscape and data processing infrastructure looks like. Couchbase eventing is a built-in feature of Couchbase, which allows you to monitor data events and use script code to do things like generate alerts, propagate changes to other systems like we've been doing, and enrich documents. So I encourage you to check out other sessions on this topic. I'm sure there are some, or explore the Couchbase online documentation for more details on that. Speaking of which, I've included links here to some key resources that will help you succeed with the Couchbase Kafka connector. Documentation and source code, and don't overlook the Couchbase forums. They're monitored by lots of good people inside and outside of Couchbase, and you can get lots of great answers there. Good forums are terrific. Finally, whether you're just getting started with Couchbase and are looking to integrate it with your applications and with other systems, or if Couchbase is already a big part of your data management strategy and you are now looking to leverage your data to gain greater insights for your business, Couchbase and Inspired Intellect can certainly help you out on your journey. Thank you so much, and I hope you enjoyed this Connect Online session on building real-time data pipelines with the Couchbase Kafka Connector.